Assalamualaikum and good day. My name is Engku Amirul Syam bin Engku Sanusi. So today I'm going to present about development of the oxidation methods by using eddy current with Internet of Things. So this is my poster and I will zoom in the next slide. So first of all, this project description is about the ionization method, which is specifically with the frequency depends on the user setup. The purpose is to detect the magnetic field on the surface metal and collect the voltage to the main application. There are benefits where the problems can be detected early before catastrophe happens. So for the introduction, as we know, the corrosion is a threat for the base metal to oxidize the thickness on the surface metal. The base metal, for example, is lead, copper, nickel, and zinc. Eddy current have several types to detect the crack and oxidation. Metal that doesn't need physical contact, the type of eddy current, and which is TT, transmitter and transmitter probe, TR, transmitter and receiver probe, and lastly impedance probe. The suitable probe have sensitivity and able to capture on the surface metal. The next one is the problem statement. So the first is the metal that exposed to water and air pressure. The second is the thickness and crack on the surface metal. And the last one is the maintenance need to go down the field to checking on pipes. So the next is objective, which is to study the oxidation metal, which is base metal, that occur when it exposed to chemical reaction and environment. Next is to develop eddy current sensor to analyze oxidation on the metallic materials. And then lastly, to notify the observer when the metal has reached the oxidation phase. So this in research methodology, as the left side there are components that creates eddy current, which can be seen in the flow chart on the right side. The power supply, the probe, the transmitter, and reacts the magnetic fields to the probe transmitter as the voltage reading in multimeter in millivolts and low value can get in microvolts. The amplifier helps the voltage reading values from the lowest until the highest that can be detected by multimeter, but in less accurate range, and blink can be detected from it with suitable value that can be read. So for the result, the left side of the calibration of 220 volts sine wave without distortion, and the right side is 12 volt with distortion output transformer for test the voltage sensor, which I'm using the voltage sensor ZMP-T101B. Before that, to test the receiver probe, the transmitter has been tested with the multimeter to get the reading. The reading shows on the voltage slightly difference between metal with 49 millivolts on upper corrosion on the metals plate, and this and the below plate is 335 millivolts on AC voltage. The current shows the same reading as the current flow in the series circuit. There are two types on the surface metal with the same type of metal. The voltage shows unstably after the flow into amplifier. The amplifier also have distortion that may affect the reading become unstable while checking the surface on the metal. So for the conclusion is the current flow creates magnetic field and heat transfer from the first magnetic field to the second magnetic field. The voltage sensor can be used although the distortion may interrupt the reading as well as the amplifier that amplifies the voltage from the receiver probe. The blink application is used to read the readings from the sensor and creates graph on the same application. For the project features they may include inside the project is there have voltage measurement. The second is provide with Wi-Fi communication to the smartphone, which is met with the requirement IoT. And lastly, the graph can be shown in the application. For the project potential of commercialization, as we know, the eddy current is widely used in aeronautics, automation, shipping, and oil and gas industry field. Therefore, it can be expanded to the other field, which is may include to machine or pipes that always exposed to the environment, such as SAMB, Suruhan Air Melaka Berhad, Suruhanjaya Air Melaka Berhad Water Supply for locals. Although nowadays the coating for each metal is used can prevent from rusting for short terms because of stress on environment, but in the meantime, periodic inspection is important to prevent catastrophic incident happen. Thank you.
Okay, as we can see, there are several of circuits. This is amplifier circuit, this one is 5 timer circuits, and this one is bridge rectifier circuits. So this part is for the prop receiver, and this one is for transmitter prop. So this one is power resistor that can flow the power, which is stable the power for input and output from this transformer. So it needs for load to stable the voltage out. So okay, this one is I'm using for a blink application, and I'm using Node MCU for microcontroller, and I'm using this, which is a voltage sensor that capture in AC power. So next we can go to the next one. So we can test the probe, which is we can test the probe transmitter first, which the magnetic field has induced for the first one and transfer to the second one to transfer the second one metal. So as we can see, the magnet has been forced to the magnetic field has been captured. Magnetic field has been produce a magnet to produce sound like this. But if you switch off the switch, the magnet has not formed anymore. So the next one is receiver probe. So receiver probe comes from the amplifier. So if we turn on, the blink should show the reading for the transmitter for the receiver probe. But there are problems, because the amplifier has some noise or distortion, which can be the reading is higher than the theory value, which a theory value must be 4.0 volts, but in the reading it shows 15 volts to 17 volts, and for the both metal should show the difference between them, but there are no difference at all, because the amplifier problem. And then but for the voltage sensor, it has been calibrated for 220 volts and testing to 12 volts, but the amplifier have its own noise, but the reading is unstable sometimes. So that's all.